Welcome students, we are going to learn one more experiment, that is photodiode. The aim of the experiment is to study the reverse IV characteristics of a photodiode for different intensity of light incident on it and determine its responsivity. The apparatus we require for this is photodiode, light source, power supply for the light source, DC microammeter and DC voltmeter. Let's see the device once. So this is your photodiode written as PD. This is the LED, that is light emitting diode, and this is connected to a power meter whose power we can vary. So this is the photodiode kit, which has DC voltmeter, DC microammeter. It has the resistance. It also has the variable battery, which we can vary with this knob. Let's see the connections now. Connection should be according to this diagram. So see this diagram, there is a battery of 3 volts, there is a resistance, there is a ammeter in series, there is a voltmeter in parallel, and the photodiode is also connected parallel to the battery in the reverse way. That is, P is connected to negative of the battery, N is connected to positive of the battery. Let's go to the connection here. So the connections are from C to C and D to D. That means you are connecting a voltmeter parallel like this. So here is our ammeter. Ammeter connections are E to E, F to F. E to E and F to F. So the ammeter is connected in series now. Okay, this is the battery here, and there is no internal connection, hence a wire from A to A and a wire from B to B. So here we want the photodiode, but photodiode is kept here. So this is the positive of negative of the battery. This is the negative of the battery, this is the positive of the battery. But our photodiode is here. This is the positive of the photodiode and this is the negative of the photodiode. We need to connect this photodiode in the reverse way. That means the positive red side of a photodiode is connected to the negative of the battery, and the black color of the photodiode is connected to the positive of the battery. Now switch on the source. For this, here you have 2 buttons. Let's switch them on and also switch on the power supply button here. So the LED is glowing now. We need to cover this with this black thing, that is all the energy, light energy from the LED will be absorbed by the photodiode. Now set this value. Set this value. There is a arrow mark on this knob here. Set this value of the power meter of the LED to 10 milliwatt. This is the LED power meter. Look into the values here in your tabular column. So photodiode current, we want the LED power of 10 milliwatt, hence we have kept it to the 10 milliwatt power of the LED. Okay, this is the knob where you can vary the voltage. If I increase, voltage increases, reduce, voltage reduces. Start increasing the value of the voltage here with this knob and note down the current. For example, we want it for the 0.1. For 0 volt, the current will be 0 here. Now increase it to 0.1. With this knob, I am going to increase this to 0.1. Set it to 0.1 value. This is very sensitive. You need to do it very slowly. Okay, 0.1. Note down the current as 4 microampere. So this is 0.1. I am getting it as 4 microampere. Now increase the voltage to 0.2. Note down the corresponding current. 0.3, 0.4, 0.5, 0.6, 0.7 up till 0.1.2. the values of the current goes on increasing and it remains constant, right? For example, you can see the curve here. If you plot a graph of reverse voltage versus the photodiode current, which is the negative one since it is reverse biased, as you go on increasing the voltage, current increases up till a value, thereafter it remains constant. Hence your readings will be, they go on increasing in a order and it starts remaining constant somewhere. Take the readings up to 1.2. Now change the photodiode power to 21 milliwatt. So your LED power meter is here. Increase the power to the 21 milliwatt and correspondingly change the voltage reading. Note down the photodiode reading. This time again the current will increase to the more value and it remains constant, which can be understood easily by this second curve. Current increases in the negative direction and it remains constant. Similarly, change the power in the third case as 10 milliwatt and change the voltage, correspondingly note down the current value. So this time again the current increases to more value and it starts remaining constant. You need to plot the graph for all the three values of current with respect to the voltage in one graph only, that is in the third quadrant, taking voltage along the negative x-axis and taking current along the negative y-axis. You get three curves, that is 1, 2 and 3. Choose any two curves. For example, if you are choosing these two curves, PLED or power of LED for the first curve is 10 milliwatt. Power of LED for the second curve is of 21 milliwatt. Okay, whatever last value of current you get, draw a dotted line and join it here. Note down this current here. Similarly, for this curve also note down the IPD, that is current in photodiode 1, current in photodiode 2. Now using this equation, that is responsivity of the photodiode, you can calculate the responsivity IPD2 minus IPD1 divided by PLED2 minus PLED1. Calculate this value, you get this in milliampere per watt. Okay, after this we need to calculate the error in the instrument or error. To understand the error, we are going to find out the quantum efficiency. Quantum efficiency of the photodiode can be found for different wavelengths with this formula: eta equals to RHC divided by lambda E, where R is responsivity, H is Planck's constant, C is velocity of light and lambda is the wavelength of the light. So we have used white color here, so we cannot give the wavelength for the white color. We'll do it for the three cases. One is for red color, 650 nanometer and 589 nanometer, and one more is for the 450 nanometer. So by using, for example, if you are doing it for red color, you find out the eta by using RHC divided by lambda into charge of the electron. Substitute the value, find out the efficiency, that is quantum efficiency. Similarly, do it for two more colors, that is yellow and blue. Thank you.